So I can go ahead and start. Thanks for joining us for our final presentation and project conclusion of the Newport Creek Area Drainage Study. This is going to be a kind of a final presentation of what the recommendations are and what the next steps the city will be taking. Just looking at the meeting agenda, we're going to pause a little bit before we start and have some discussion about the rules for discussion. Introductions of the project team. Whoa. Reviewing our project goals, making sure that we are aligned with what we said we would set off to do. Reviewing the findings, and then, as I mentioned, speaking about the long-term and short-term recommendations. And then we'll open it up for any questions from the attendees. Heather, if you'd like to talk about rules.
Sure. So we've had some problems with Zoom bombing. So we are running this as a webinar, which means all attendees are muted. You can raise your hand virtually, and that's down at the bottom of your screen if you do have a question. Your screen sharing is off and your video camera is also off, again, with the webinar. And then we do have a Q&A feature at the bottom. It says chat on here, but it's really this Q&A feature. So if there's a question that you want to put in there, then you can submit it and I'll read it out loud and the team members can answer that. The meeting is being recorded. It's already being recorded. And then we just ask that you are respectful of other people's time and statements. All right, thanks. Go ahead, Jen.
So introducing the project team, the three of us are on the screen. My name is Jennifer Lawson. I am the Water Quality Manager in the Systems Planning Unit for the City of Ann Arbor. Heather, we've heard from as well, the Community Engagement Specialist in the Systems Planning Unit as well at the City of Ann Arbor. And Jamie Burton, engineering firm of Hubble Roth and Clark. He's our project lead. The fourth member of our team, Harry Sheehan, the Deputy Water Resource Commissioner, was unable to join us today. He said he's going to try to get away. But he is not able to join us right now. Jamie, if you'd like to talk about the project.
Great. So good morning. So the progress is, as Jen has mentioned, it's really, this is the final report and the final set of presentations. But what we've done is gone through this 5-step process to get here, which is we went out. We gathered all available information from the city, from stakeholders, anybody we can get a hold of. We evaluated that plans for past developments, road information, anything we could find. We took that data and we went out in the field and we did a pretty robust data collection system. We went down the stream. We took survey information at different cross sections, but also collected visual data, and it's all referenced into GIS. Put all that together, came up with some general site system conditions, system impacts, kind of the lay of the land. We discussed a series of coffee hours, what some possible solutions and recommendations for these problems are. Take a little bit of feedback on that and generated the final report. And then this is the summary of that final report today. The main 4 areas of concern were the stream banks themselves in relation to erosion, what needed to be stabilized, what are the opportunities to make it a more natural type system, but still convey various levels of flooding and or just general flows. We did look at the existing stormwater detention ponds. Most of these are, I think all of these are private, but we did look at how they were performing and opportunities there. We've looked for opportunities to increase storage or stormwater detention in the system by building new facilities in existing upland areas. And we've also identified certain areas which we've called pinch points, which are just impacting the hydraulics, the ability for the stream to carry different size storm events, different size flows. So kind of walking through each of these categories, these are the map shows what we found in walking both branches. So Newport comes off the river and then branches, west branch, east branch, west line goes by, west goes near the high school, west goes through, east goes through subdivisions. And Green, yellow, red kind of highlight the areas of concern of increase or significant bank erosion or stream bank failures that have occurred out there. We'll get into some of the percentages in a minute, but what we found out there is very typical of an urban stream system or an urban creek system. So it's nothing too alarming. It's just a matter of kind of characterizing that. So the different stats on these areas, about 22% of the banks are eroding. We have to know that stream banks in rivers, natural systems move. Natural systems will go left and right and up and down over time. So just because something is eroding a little bit does not mean it's a bad thing. It's part of the natural process that a rivers undertake. It's when they become significant, severe, or cannot be mitigated or stabilized naturally that they become a concern. It's everywhere in the system. Regardless of severity, each different section, it's kind of got the same amount. If there's not one very large hotspot that's all over there. But of those areas, most of them were significant, either moderate or severe types of erosion. We also looked at different things that were out there. Again, wood or trees or brush in the stream system is not a bad thing. That provides cover for different kind of animal, wildlife. It also can provide stability, but sometimes it can make instability. We found quite a bit of blockages related to log jams and sediment bars out there, just under 40%. Fallen trees that have either fallen due to disease, due to age, or they were in the riverbank, and then the riverbank had moved a little bit and fallen in there. We did find quite a bit of those. We did find some deposition. So the opposite of erosion is deposition. So it picks it off the banks and then deposits it somewhere else. Found about less than 5% of there to be some deposition. Some of that can cause problems. That's a sign of instability. Sometimes it is not. It's just a part of the natural process. So you see there's a number of privately owned detention basins in this system as identified in all of these green dots. We went out there and pulled whatever plans the city had available on these systems, and then went out in the field and compared them to files and kind of made references from there. So the different A through Q just is which of the ponds, what types of ponds they were. These are just kind of the basics, what they are: residential, commercial, trying to figure out, what were they supposed to be, wet or dry basins. And then we went through all 17 basins with these kind of parameters. Is there deposition sediment? Are they completely vegetated in with something that shouldn't be there, invasives, for example? Is there blockages? Is there flooding, excess flooding? How are these basins really holding up? Are the buffers needed? What needs to be done? Of the 17, 11 are recommended for additional maintenance. And basically, these have to do with normal routine things. Most private detention basins do not have a routine plan. They kind of as needed by the association or by the homeowner group. So this is, again, very common, but it's definitely significant when you look at how many basins there are and how many of them might have a little bit reduced capacity. We've identified several areas of open space, maybe publicly owned, school owned, or just kind of these open areas that additional stormwater detention and volume could be provided. That will help reduce flooding, help buffer the system for the flashiness of flows as they up and down. It provides real good, some buffering of the overall system. And we went out to each of these sites, evaluate them for the potential, starting, desktop, can they be expanded? Are they readily available to increase storage? Are there floodplains? And I'm not talking about the 100-year floodplain. I'm talking just out of bank, out of area. Are those able to kind of, can they flood? Can they store water? Or were they just kind of bypass and go someplace else that we don't want them to go? And we really focused in on what could be done practically. And that includes, enough room, enough elevation, and where in the watershed. One at the very upper end might be great, but one at the, somewhere in the middle where the branches come together might have a little higher priority because it has a better input upstream and downstream. One at the very outlet, it's kind of, everything's getting there first, and we want to provide some like along the stretch. We also know, and some of these are very wooded, very, maybe they have a lot of hills or a lot of slope to them. So just how much disruption would have to be done to put these into some sort of storage. And then just, dollar per square foot, dollar per cubic foot. We have to look at this in terms of cost at some point. Just, how expensive is it to get 1 gallon of storage versus another each site. So we found a few of those that we thought were worth pursuing. One is up by Skyline, offline pond or wetland complex available. Second one would be at Newport Hills Condo Association, where the two branches come together. This is more of a in-stream storage. So this would be opening up the shelves, opening up the cross section so that as water came in, it had a place to go versus kind of channelized downstream. And then the nature area, Riverwood and M14, again, owned in Harbor Public Schools. This would be kind of restrict the flow, hold back water, create some wetland habitat, provide flood storage as well. There are a number of hydraulic pinch points or areas that kind of control flow, especially down at the railroad tracks immediately upstream. So we went and did some hydraulic modeling. We pulled the US EPA model. It's called the SWIM model. And this is where you take rainfall events and you simulate how the system reacts to that. So this is how we got a base model set up, and then we put in different kinds of storage to evaluate how those potential improvements, namely storage, would impact. One of the things that contradicted what we heard from residents who live along the stream was the model didn't show any flooding up to the 100-year storm event. Again, this contradicts a few residents saying, no, I flood, and here's kind of the events, rain events that flood. What we recognized is the FEMA model and kind of the graphic up on the right or the picture down on the left. FEMA defines flooding as kind of coming out at the higher of the two banks. So that model is limited into showing when areas flood into what event. And so I think that's real important when we talk about, well, there's no flooding under a 100-year event. Well, there is. We've seen some evidence of that, and it appears that that's accurate. Just the modeling, the technical resources that just don't support that, but we found out why kind of defines as you're kind of looking at those photos. So we were able to correlate technical data with field data with resident input to show that this, there is areas that are potential could flood. So we added about 1 million gallons of storage, and just really looked at how that would input peak flows, of how high, how fast does the water go down. And we put it all at the end only from the idea of just it impacts the whole, all the flow goes through it versus east-west, Skyline only through the middle. And basically we came up with an idea that if you added this amount, 1 million gallons of storage, which is about an estimate of the open area between Skyline and Newport Creek Drive, you would be able to reduce the 10-year peak flow by about 8%. So that's a pretty decent reduction. It's expensive, but it is, that's not insignificant, okay? 10 years simply means that any given storm event, you have a 10% chance of exceeding a threshold. That number is constantly moving based on climate data. It happens pretty frequently, especially this past year. It's happened a lot. But that, adding storage would definitely show a minor impact or improvement on that. So what are the basic solutions? We're recommending stream bank stabilization. Some of this is in digging out the channel and redoing it. Some of this is adding low impact design, low impact development type features, stone wood, tow wood, vegetated banks, adding some in-stream structures to make sure that the grade is controlled so that it can't go vertical or too far horizontal. We do think that the first item of business is to optimize the existing storage that's there by cleaning out, restoring, any existing ponds. Then you would go in and add new areas. And in areas where you were doing stream bank work, you would look for additional floodplain storage by building a two-stage channel, low flow and an upper flow channel. But you wouldn't go wholesale, do that end to end until you explored and exhausted the first two options. And then there is some culvert downstream to modifications at the downstream crossing and the railroad crossing, where you could look for modifications. Then flood tubes are in the picture in the lower right. That's just kind of adding additional capacity with smaller culverts offset. So going and putting a little bit of cost in there, short term, getting to each of these private stormwater detention basins and cleaning out each of these basins would be a great way to start making immediate impact. And those are in areas that maybe the city or county can't get to right away anyways, because again, they're on private property. Rain gardens would be of benefit, but you would need a lot of them to make a significant impact. Downspout disconnect. And then there's 2 or 3 big blockages that are out there that could be, this is an old trench box, and there's these old pipes and these old things that are out there, old structures, old crossings, that if we could remove those would be, have some immediate, these are very that would be a very cost-effective improvement to be made. So long-term improvements, we got to get in there and do some stream bank stabilization. We talked about adding new stormwater storage, address the pinch points, floodplain culverts, and we put in some average costs of each of those. These would be built in over time in a phased approach through the city's CIP system. Adding, so overall potential CIPs for the year or for the project does not include easement costs. None of this work is on any kind, other than where it crosses the road. Schools are quasi-municipal, but none of this is on city-owned or county-owned property, would require easements. So we have not included those costs. But generally, here's what you're talking about, working our way through to provide new detention, new wetland complex, repair the entire system. Again, you wouldn't do the entire system end to end per se, but definitely you have to kind of plan on ultimately getting to all of it. So here's the CIP summary. So what do we do from now? So the city decides what, or if any of these projects do get added to the city CIP, which is citywide, not district, not watershed based, it's citywide, and are prioritized based on city needs and budgets. And then the city would work with Washtenaw County for a petition process to either convert this to a county drain, or to convert the sections of work into a county drain for those works, so that the county then could go ahead and proceed to do the work under the drain code. So that's kind of the next 2 steps of the process. With that, I will turn it back over to Heather to facilitate, moderate any questions that I can answer.
Sure. And really, since we only have one person on the line, if you want to raise your hand, if you do have a question, I will unmute you or allow you to talk if you just wanted to ask your question directly. All right, you should be able to talk.
Hi, can you hear me?
Yeah, we can.
No, I didn't really have a question. I am sitting right on the creek, and I just wanted to thank you for this and for the concern and for the work that I've seen people doing here. I've watched them walk by my window. And at the moment, I've got 3 rain gardens, and I'm watching the flow going by in Newport Creek right by Lowell Road. Feel protective of it, have in fact suffered one of those 100-year events early upon living here about a dozen or so years ago. So I know this can happen. And I'm just an interested citizen, really pleased to be working on rain gardens with Susan Bryant and the people in the county, and hope to keep convincing neighbors and others that that's a very important part of what citizens can do to feel that they're making their contribution. So thanks for the work, and we'll keep an interested eye on what happens next.
Yeah, thank you. Thanks for joining today.
It's important.
Yeah,
Thank you.
thank you.
Jamie, thank you for the presentation.
You're
We
welcome.
will have another coffee hour presentation this evening at 7 p.m. With the same information. And with that, we can complete the public meeting and enjoy the rest of this rainy day.
So I
Thanks,
have to
all.
say, I was a little distracted because I had two deer, quite literally right outside my window. And I was kept looking up and seeing this very large deer right there. So I just kept trying not to be distracted.
Mother Nature at her finest.
Yep.
I see you have your hand up again. If you have your,
Just that you touched a sore button here, because we have so many deer with Bird Hills, and we've fought really hard to try to preserve the natural areas particularly. And we have a herd of about 5 that walk through here every night. But I have a fence at this point, so I can grow a native prairie in my backyard and really enjoy nature. But deer are a significant problem, and I wouldn't be surprised that a lot of the invasives you're finding in some of these ponds help get spread by the deer that are walking around, especially garlic mustard and some of the other things that we see.
Mhm.
Anyway, thank you.
Well, thank
All right,
you.
well,
Looks
thank
like
you.
I think Jen's
Lost her
internet went
internet
out.
again.
So, yeah.
All right, Heather, we'll see you tonight. Thank you.
Okay, sounds good. All right, thank you again.